Good morning, mathematicians. Sorry about the noise. And Galois Cohomologists. We're back. I think we were about here. I think I was skimming through these things. Oh, I gotta go open up chat. Part 8, I think, of the Galois Cohomology saga. Whoa, I got a whole bunch of notifications. What is it? 6? Except, half of them are probably just telling me about videos. I don't care about that. Part 8, I think, of the Galois Cohomology saga. Whoa, I got a whole bunch of notifications. I'm psyched about the amount that my subs are climbing. But I also think it's because of purely because of my recent crackpot video. And I feel like I have things to say about it and reflections about that video. So maybe that will be coming out on Friday. Quite possibly, we'll see. Is anyone here? You guys gotta let me know if you're in chat. Legally, you have to let me know. Yeah, we did talk about this stuff. And I'll even remember to switch to live chat right at the beginning. Yeah, crack pottery sells. It's true, Rod. I don't know, but then the question is it moral to make fun of crackpots? I mean, I feel like morality doesn't exist in any objective sense. But still, can be more of a nice person or less of a nice person. What kind of person do I want to be? I don't know. I'm going to talk about it in... I don't know when I'm going to post that video. A week or 2 weeks, depending on the order of things. So... you see now, morality does not sell. Yes, that is true. There are no popular puritanicals. I shouldn't say no. There's probably, I don't know. There's probably, I don't know, very moral YouTubers. But, yeah, it's much easier to just have terrible, hateful content. Do I want to proliferate that? I don't know. Those are hard questions to answer. Let's turn to something significantly easier. Galois Cohomology. So, the first homology group turns out to be isomorphic to the abelianization. In fact, they even say canonical. I think they should say the word functorial, to be honest. I think that is a better way to express this thought. But whatever. Who updating they Yeah. I know you are, Boris. That's why I do it. Okay, throughout this section, G is a finite group. We got a G module. We got our norm map. Functorial, yeah, natural's kind of loaded too. Yeah, I guess it is. I think natural transformation. I think the better way to say it, I know... Whatever. I've softened up on a lot of things. There's a lot of things I was very, I don't know, stringent about the way we write things or say things, and equality versus isomorphism, here. But, yeah, I don't know. Can the norm map make you normal finally? Well, maybe, actually, because as you can see here, we're going to quotient out by the image of the norm map. So actually, probably what's going to happen is it's going to make you less normal, because we quotient out by the image of the norm map. Then everything that was normal is going to get killed in that. So I would avert your eyes from the stream now if you're trying to be more normal. I Yeah. Yeah. Okay, so we got the norm map. Turns out to be it's a module homomorphism, of course. Why else would we do it? And then we've got IG, right? And let's just remind ourselves that was the augmentation ideal, right? That was defined to be the kernel. Right. So we have a kernel. Yeah. Kernel of the augmentation map, right? So okay. Then we get a big commuting diagram, which I'm willing to just believe. We've got our facts about homology and cohomology. And the bottom row of this can then be rewritten as here. What's the punchline? Tate defined the following groups. Oh. That, okay. That actually, I understand. Like, you just glue together the homology and cohomology. I had no idea. That seems like just a very simple fact I would have read before. I'm reading it now, I guess. Whenever you want to describe something and you don't want to invite questions, say yes, but the moral way is yes. Yes, exactly. Yeah, that's a good trick. Yeah. Tate cohomology, for instance, becomes much nicer to define in the derived category because it's just the homotopy cofiber. The homotopy cofiber of what? But that is nice to know that there is a uniform description of Tate cohomology. That's not just like, oh, I randomly define these groups. I mean, I was anticipating there was going to be a statement like this that stitches these things together. Good morning, Ken. Good morning. Then the sequence becomes this. Take cohomology groups. Sometimes we do them with an H hat. Okay. And since it causes no ambiguity, we sometimes omit the subscript T when R is bigger than 0. Okay, I mean, I guess I'd rather you didn't. But whatever. Doing a reading course this semester on sheaves and check cohomology. Nice. That's true. Arad never misses. That is true. In the context of algebraic geometry or just topological spaces? Yes, good question. I would also like to know. On applying the extended snake lemma, we got a big exact sequence here. Okay. Then we also get, I guess this shouldn't be so surprising. Yes, because when R is greater than 0, we've already seen this. When R is equal to 0, so let's go up and see what was R equal to 0. That was the fixed points modded out by the image of the norm map. So M is induced, which means precisely that. And so an element M of M can be written uniquely in that form. Uniquely in that form? Oh, yeah, because I guess it's a Z basis. If M is fixed by G and G prime, then this equation holds by just... Wait. Oh yes, that should be true. So in particular, G prime X is that... okay. So it has to be G prime is E. Therefore, if that is that, then that is that. And then, right. All the coefficients are equal. Okay. More topology focused. Research in applied topology. Okay. You did start reading Yek's chapter on forcing, and it definitely gives off very sheafy vibes. That is interesting. That is very interesting. I feel like we're so far from this actually happening, but that is definitely, a possibility of where Who Gives a Sheaf goes one day. But we're very far from that at the moment. Okay, do I want to read all of these proofs? I don't know if I feel like reading all of these proofs. I mean, case R-1 does make sense, actually. That's a very short proof. I guess maybe the more she's upon you and your kid. Yes. Good morning, Sawdust. You like it, but it's a little unconventional. Ran in intro to topological data analysis. Is that what that means? You usually recommend the first half of Bloomberg Rabadon TDA for genomics and evolution. That sounds cool. I do really like I like geeking out on biology stuff sometimes. I don't know if you guys know Robert Sapolsky, but him and his daughter have been doing, it's called this father offspring interviews. Well, it's mostly just him answering questions from viewers, but it's great. I love listening to that. Indeed, Boris, good question. Cap or no cap? I hadn't heard anything about it one way or the other. I only would have imagined that topological data analysis would still be blowing up in the age of AI. Although I guess, I don't know, maybe AI is superseding it, or I don't know. But certainly somehow you should be able to like glue it together with AI. I don't know. Jack. Yeah, so this is really the thing of substance, because we're talking about homology here. Right, this is a quotient of a free abelian group. The kernel of this map will also be a free abelian group. There's a footnote here. We are using that every subgroup of a free abelian group is abelian. I see. This fact is highly non-trivial and non-constructive. Oh. And that it is possible to avoid using it. Cool. The kernel of this map will also... and so we have this short exact sequence of free abelian groups. We tensor up to get a short exact sequence of Z modules. Why is this statement true about the Tate cohomology groups? For R less than 1, those are free ZG modules. Oh, they're free ZG modules. They're free ZG modules? Why? Why are they free? We just tensored up. But we tensored up over Z, right? So I guess they're free. Wait, isn't everything in the situation free? Now I'm confused. Oh no, okay, yes. We tensored up some free things over Z. The new things are free. ZG is free, right, okay. Makes sense. Because, it says because they're induced? Well, Not everything induced is free, but sure. I mean, I believe they're free. Free Bee Gees module? Free the Bee Gees, that's what I say. They've been imprisoned in this realm for far too long. The very long exact sequence of 23, right, yeah. All the other cohomology groups are 0. So we're done. Cool. That all checks out. I feel ever more guilty for not doing my homework here. Let's see. I just want to skip ahead to see. Maybe we can get to cohomology of cyclic groups. That would be cool. Today, I don't know. Is that too ambitious? Let's not get ahead of ourselves here. We're pretty close to it. We know that every G module is a submodule of induced module. It is also a quotient of induced module because on tensoring with the augmentation ideal sequence, we get such an exact sequence. Sure. Seems like your message got blocked. Oh. I did turn it on live chat. But you said there's a database of TDA papers, currently has over 500 and adding more all the time, called Donut. Let's take a look. Database of original and non-theoretical. Wow, that's strong. Not applied. Not applied uses of topology, but non-theoretical. Wow, they even have an I'm feeling lucky button. Huh. Cool. Okay. So this allows us to prove results by dimension shifting in both directions. Using this, it is possible to extend to all R most of the results we proved for the groups HRGM. Right, now that we have this 0 induced for all the Tate cohomology. For example, Shapiro's lemma and its consequences are true, and the restriction and co-restriction maps we defined in these sections extend to all Tate cohomology groups. Nifty. Although I feel like the explicit calculations are getting away from me here. My feet are no longer on the ground. Moreover, there's a natural action of coset on here. The restriction, co-restriction is still multiplication. And the argument in the proof of 130. 130? Okay, well, whatever. I could just click on it, I know. Shows that this is killed by G for all R. And also note that the minus tooth Tate cohomology is the first homology, is the abelianization. Noted. Okay. Proposition 3.2. Let H be a subgroup of G. The co-restriction map corresponds to the map induced by inclusion. Nice. Cool. And the restriction map corresponds to the Verlagerung? Ich weiß es nicht. Verlagerung map. 318. Okay, we gotta go somewhere else for the proof. But let me click 318. What is this map? Thus, whenever we have a group G and a subgroup H of finite index, we have a well-defined homomorphism down this way. Okay. I feel like I gotta look this up. How's it spelled even? Verlagerung. German word for relocation or transfer. Transfer defines from a group and a subgroup of finite index a homomorphism to the abelianization. Obtain numerical results on the existence of finite simple groups. Interesting. Verschuebung moment. Verschuebung? Wait, what's Verschuebung? Verschuebung? What's a Verschuebung moment? A shift moment? Oh, sure. Okay, yeah. Big Verschuebung moment over here. I'll try to remember to say that if I'm ever like shifting sequences in the derived category. Like, all right, chat, we're about to have a Verschuebung moment here. The construction of the map proceeds as follows. Okay, whatever. I'm just willing to believe it. But I wanted to look this up. Oh, and then there, homological interpretation. Okay. So, let's head back here. Germans be naming stuff, and be naming stuff better than anyone else. I mean, it's quite literal, right? What is a lighter? It's a fire thing. What is a plane? It's a fly thing. Rod, I have no idea what you're talking about right now. The opposite of the Frobenius map? What do you mean? What, it's like taking pth roots on whatever Dieudonné modules are? I don't know. Let's just read these final things here so we can call it a day. Oh, I do want to look up Dieudonné modules. Why is this straightforward hyperlinked? Oh, let's go back. That is a good question. Where's straightforward? Is straightforward to show that? So, what? And straightforward takes you to weird. I guess they hyperlinked it like this because they meant that is straightforward if you know about art and transfer, but that's pretty funny. Be like, the proof of FLT is straightforward, and then link to Wiles' paper. Okay, let's finish this up first, and we might look at Dieudonné modules together, but maybe not. I don't know. I'm a busy man. There is a uniform explicit description of all of the groups. Oh, maybe this is what Arad was talking about. In fact, there exists an explicit complex of G modules, infinite in both directions, such that this is the G-Homs from, right, this complex of Homs, I see. For r greater than 0, it leaves exactly to directly to the description we gave above. Nice. Okay. Classic math book. Trivial if you already know. Yeah. 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 Cup products. When the group G is finite, cup products extend in a unique way to all the cohomology groups. And we have the same list of properties. See Vice. But not proofs. Yeah. A future version of the notes. Oh, he means of these notes, I guess. Will contain a complete list of the properties we need, but not the proofs, which are lengthy, but not difficult. Okay. Good homework exercises then, probably. A trivial exercise left for the reader. Yeah. You thought it was some functor, like push forward, but straighter? Is push forward twisty? Okay, so I think maybe we'll leave this here for tomorrow. The cohomology of cyclic groups. But let's end the stream. We'll just go over quickly to dude name modules and read what the hell's gonna wit vector. I never understood the wit vectors. Yeah, I don't remember the definition. I don't think the definition's complicated, but I've never had a reason to care. Dude name module, the module over the non-commutative dude name ring, which is generated by wit vectors, generated over the ring of wit vectors by two special endomorphisms called Frobenius and Verschiebung. They're used for studying finite flat commutative group schemes. Okay, why is this used to study that? Yeah, see, my eyes are already glazing over. I'm like, why? Why would anyone do this? D modules. Corresponding to D modules, connected P group schemes correspond to D modules for which F is nilpotent. Okay, roping me in a little bit. What are the wit vectors? Anyways, I know I've read this a million times. P-adic stuff. I should know this. Right, wit vector is an infinite sequence of elements in a commutative ring. Showed how to put a structure on the vectors in a way that the ring of wit vectors over a finite field of prime order is isomorphic to the p-adic integers. Well, that's nice. We like to see that. Exactly, Rod. Yeah. That's a me moment right there. They have highly non-intuitive structure. I love that there's a reference for this. I love that there's a reference. Like, yeah, if you don't believe that they're not intuitive, you can go read. We proved that it's not intuitive here. Their additive and multiplicative structure depends on an infinite set of recursive formulas, which do not behave like addition. Yeah, I literally read this article like 2 months ago, and I already forgot everything. Anyways. Oh, number theory. Okay, cyclic extensions. Something cyclic extensions. Art and Schreier polynomials. Classic. Wit seized on these polynomials by using them systematically. Comes to... Specifically, he introduced this ring. Comes with the Frobenius operator. Since it reduces to the Frobenius operator on K, Wit observed... duh, duh, duh. And he defined this in analogy with Kummer theory. And bijective correspondence with the subgroups. Okay, maybe understand it a little bit more. Always read it in a Jamaican accent. I've turned around and become completely AI because of this one video. Yeah, Revenge of the Bumbleclat. I think that's the one. Is it Revenge of the Bumbleclat? Yeah. So anyways, just do yourself a favor and go watch this. Yeah. Just do yourself a favor and go watch it. And that'll do it for today. So yeah. Go compute some cohomology groups.